we do have a problem on bit set insertion on line 188. So this one here, yeah, let's actually do this. And we need to do so this one would need to be just D, I think, and this one here would be parent node index value. Right. Okay. Let's see. Oh, of course. So the problem is on this axis here. So let's get rid of this here first. Right, so we are trying to toggle parent node 68 for some reason. Whereas we should be so let's do something like so, this, and hopefully this will give us the answer we're looking for. So this one would need to be matching bucket size, matching bucket, sorry. And then this one here would need to be node index, and that should work. Right, so our current node is 0, 10, so bucket 0 and node 10. And for some reason we are matching its root node to 68. It's kind of weird. Let's actually just do do we know how many items we have? Okay, so there we go. We have this to the order -1 -1. And actually I'm just going to add parentheses here just to make sure that we do create the correct value. Okay, so that was a problem. We did not have the correct value, and now we have another one here, integer overflow, so 1 to 7, I believe, in pointer from node index. And it's overflowing somewhere in minus order +1. How is that possible? Let's invert the order of operations. Let's see. Okay, that seems like it solved the issue. But we still have expected 64 found 127 in testing 103. Wait, what? No. 256. Okay. So our node state is 8, right? We have 8 max order. We allocate 2 to the 7th minus, so 2 to the 7th minus 1. So that's 127 we should expect. So our test was wrong, as always. if your tests are rubbish, your code will be rubbish. Okay, so here we do see that we get the correct thing. So we matched node 10. We've allocated node 10, so that means that we have node 11 here. We had node 5 in bucket 1, so that's where we allocated the single byte from. So node 5 got split into 10 and 11. We've allocated 10, so we just have 11 left in the bucket 0. That's cool. That's very cool. So that means that I can confidently say that we have a working body allocator, or rather just the allocation of the body allocator is working. And what remains to be done is to do the whole deallocation and probably handle the resizing side of it, because in the allocator vtable, we have alloc, resize, remap, and free. And I think the ones that are important are just alloc. We can just ignore the other ones, but I also want to have a free. Remap and resize are optional, since they all return optional things. Resize, we can just hard code that to be false. So that means we can't resize, and that would just mean that we'll have to replace a resize with a free, with an allocation copy then free. And I think that's what they have here. So no resize and no remap. We have these functions that can be used to replace the resize, remap, and free. I think we have no free also, yeah. Now let's do this. Alloc, allocator, maybe. That returns allocator. And then this will return. So alloc would need to be allocate. Wrong language. So let's see here. We need to build this, and it should, of course, we need to use it. So test body allocator. Yeah, okay. And here we are going to just yank one of these, probably this one. It's the most basic one, and we'll do const alloc is body allocator, and then we'll do alloc const slice is alloc dot create no alloc, and I want to allocate U64 and 10 U64s. Of course, just hit this with a try, and I'm going to try set testing expect equal something like this, and slice dot pointer. And I'm going to need to actually do this whole int from pointer business. There we go. And we'll also try this needs to be at bit size of U64 times 10. Of course, this is the length of that. Okay, and here we are going to see all the problems we have. So note, allocator is not a member function. Of course, it's not a member function. We need to take self, which will just be this, a pointer to this. Actually, yeah, that looks pretty okay. Really, allocator. Am I missing something? Okay, let's do this. See, allocator like so. Oh, okay. Well, that's fine. That is fine. Oops. There we go. So this one will be allocate. And these ones will just not be there. And now we should have a build error that will tell us that the allocate function does not have the correct prototype. So I'm just going to rename that alloc. Go under allocate somewhere here and do function alloc with the correct. So what is the correct this, I guess. Sure. Let's replace this with this, and now we should be okay to go. So add this, and we have memory alignment, we have return address. I guess we can, for now, just disregard this one, and we can return self.allocate of what's it called? Length. Yeah. We are also going to disregard alignment for now. Okay. So this one has alloc. So let me just do something like this. And here I'm just going to add step.mem.alignment, and I'm just going to go up here and do this. Right. So now we are going to just give it the other fields, and this one here would just need to be stud.mem.no no reside. Isn't that where this is? Oh, it's under mem allocator no resize. Cool. What was the other one? Remap is stud mem allocator no remap, and free is stud mem allocator no free. Oops. There we go. So for now, expected a many item pointer of U8, but found a slice A. Okay. Bit too far there. Okay. So let's see. Okay, so I guess we just need to change this to, instead of outputting a slice of U8, we should just output the so let's just do this, I guess. Is there any other return? I think there is, and we can just do just return that there. And we can get rid of this. Okay. Almost there. So does not support field access. That's okay. So I guess we have all of this to fix. And I guess we not really need, or we can't test the sizes anymore. So dot pointer, let's see. And this all just comment out. All right. Okay. This one I'll comment out. All right, that's fine. This one is out. Okay. All right. And this one here is for length. Well, first of all, let's get rid of that, and then we'll just... Okay, so int from pointer slice found, expected pointer found U64. Oh, okay, so this one here was correct. All right. Okay, so what is the problem here? The problem here is requested size 80, line size is 80, and we match it all the way down there. And of course, right, so we've tried to allocate a slice in a memory that we don't have. Cool. So const buffer is test alloc dot I guess create you alloc U8 for 128. Okay, and we'll just try that, and we'll defer test alloc dot free buffer. Okay. Okay, so here I'm going to do add int from pointer of buffer.pointer, and memory length should be buffer.length. Min size is 1. I'm just going to replace that by bit size of, or just size of, I guess, U8. Oh, right. Let's see. Unable to evaluate comp time expression, of course. yeah, we had to tell it that this needs to be comp time. So does that mean that I can actually, instead of just using this buffer, I could do 128, or I could do something like this, 0, U8, something like this, and do that. Of course, yeah, okay. So we do have a problem because the address of this buffer here, or as a matter of fact, any buffer that we can allocate, is tightly related to where the linker will put it in memory. And so that means that we cannot use that as a comp time value. So this body config here will not be comp time, and then all of these will not be comp time either. So that's a blocker. Well, I guess instead of having to rewrite the whole thing to be not comp time, I'm going to... so let's think about this. We have an init that takes an allocator and returns self. But we still need to have the memory length in here. I guess the only thing that we need is this memory start. That's the only problem that we have. So let's see if we do something like, so if built-in dot is test, I guess. No, there's no is test. Maybe it's not STD, it's built-in. Okay. Let's see. So if built-in dot is test, yes. So this should be true if we are in the test. Just going to copy this. Going to call that init test. Actually, I'm gonna have to invert this. Yeah. Else, let's do compile error. Init test cannot be used outside of this thing. Sure. And in here, I'm going to also take a memory start. Should be a U64. And I will have to do So self memory pointer, or rather this memory here, I'll just do that there. Something like so. And just before this, I'm going to also copy that and do this. Let's call it pointer and use it there. So now that we have that, we can go ahead and do init test with the allocator and with the int from pointer buffer. Right. And this here we can just set to 0 for now. Okay, let's see. Okay, well, let's set it to 1 then. Access of union field pointer while field array is active. Where is that? Okay, so it's somewhere over here. Oh, right. Yeah, that should be fine. What is this problem? So allocator 412. So is this the problem? Oh, maybe it's this the problem. Yep, okay. Got it. Right, so I'm just going to bring that there. Oops. Clear and rerun this. Okay, so we have a bit of an issue. Segmentation fault found at address, whatever that is. Okay. So is that an alignment issue? Right, well, let's have this aligned to I guess we should do something like this. 128 U8 align 8, and we'll see. Okay, same problem again. Segmentation fault. Right, well, you know what, let's do stud debug print, and we'll do buffer goes from 0x this to width size d, something like this. And here we can do buffer and buffer.length. Let's see. Oh, super. Very nice. Int from pointer of buffer. Okay, so actually we do have a problem. We have a bit of a problem. I hope that it's just the log that's not correct. Okay, no, that's fine. Okay, it's actually okay. Right, so we do have our buffer right there. But for some reason, we also have a segmentation fault when we try to access it. And why is that? Oh yeah, of course. Let's do something like this. So I'm not seeing why the segmentation fault. So it's not the alignment. At least I hope it's not that. No. It's still giving us a segmentation fault for some reason. Actually, I'm just going to do buffer is test alloc dot create alloc u8 128 u8. Just get rid of that. Go there, hit with it, try, and we go again. Right, so buffer.length. We actually, no, never mind. This one here we can replace with 128. There we go. Right. So here we have expected this. Actually, expected would need to be int from pointer of buffer. Right. Okay. And expected whatever that is. And we found 10. So 128 of U8s. Where is that? Oh. Well, never mind then. Yeah, it was all right. It was all right. So now the problem is that we are expecting. Oh, wow! Right. Okay. So slice.length is actually the number of items in the slice. Yeah. Okay. Never mind then. Never mind then. And we do have a leak. A leaky leak. So I guess we need to defer this alloc.deinit, or rather just defer that to free buffer. And that should fix our test. Yes, it does. Great. Okay, so we do have a working allocator. We just need to basically do the freeing, and then we'll be able to build up on this and get ourselves a very efficient heap allocator for our operating system. Pretty cool. As one of the greatest philosophers of the 21st century, Dora the Explorer, said, we did it. That's pretty much it for this one. If you've liked this type of content, hit like, subscribe, leave a comment if you have questions or remarks, and until next time, I'll see you. Fucking out.